Okay, so let me talk about the document and what we can do here. I'm going to start with this graphical presentations used. So I said in this section you should explain spine plots and double-decker plots and how they differ from regular bar graphs and from each other. You should include some references. Now, why do we want to do this? One reason is we want to show that it's important to display the data in a good way so that you can understand what it means. And so I would, and then after saying that, then you explain how spine plot and double-decker plot are examples of this. Now, double-decker plot is an example of spine plot, so you should explain spine plot first, and then double-decker plot. So let's look at how this is. So you say in statistics, the concept of models is this word is not correct. In relationship of input variables and dependent variables and their distributions, there's many model classes. These are certain plot ensembles which make the selection and assessment of inputs more transparent. Okay, so what you're saying here is that you want some visual representation to show the relationship between variables. Okay. So let's see. Can say, all right, so we can say something like this. Okay. I can say so. Okay, it is a common saying that a picture is worth 1,000 words. Okay. In statistics, this saying means that graphical representations visual or graphical representations of data can be the best way to show relationships, interrelationships between the quantities. Okay. Well, let's see. Okay, so I may change this between the quantities being measured. Okay. There are various types of graphical representations. Okay. The most common. One of the most common is the simple bar chart. Okay. However, the bar chart is limited in the information that it can convey. Okay. So there are modifications that give more detailed information. Okay, two such modifications are the spine plot and double-decker plot, described below. Okay, let's see. Okay, and then say, let's see. So you can say for this reason, data visualization has become become an important and active field of study. And then here you should give some references. Okay. All right, so let's see. So I will take this off, and then we can see what happens when we compile again. Okay. All right, so you can give references to data visualization. Okay. Then see. Let's just say one of the most common tools, graphical tools for data visualization, for visualization of categorical data. Probably, we can say probably the most common graphical tool. The most common graphical for visualization of categorical is the simple bar chart. So let's see. So now we're talking about spine plot and double-decker plot. So we are now down to, let's save this and see where we are. Okay. So I think we don't need this first sentence because I did that. Now here you mentioned double-decker plots. As I said, double-decker plots should be mentioned second, because here you say double-decker plot. Here you mention some things that have not been defined. You see, double-decker plots are optimized the comparison of all crossings of all input variables, and double-decker plot is the most efficient. All right, so we can talk about that. In double-decker plot, the conditional layer of the mosaic plot, but you have not defined mosaic plot. You can't talk about mosaic plot if you have not explained what it means. Okay, it is linearized by putting all category crossings side by side, just as in a spine plot. You can't talk about spine plot because you have not explained what that means. Okay, the double-decker plot is nothing more than a mosaic plot with splits only along X, but with additional labels. All right, so you haven't explained what X is. So there are many things here that are not explained. Also, double-decker visualize dependence of one category typical binary variable on predictors. Okay, formally, mosaic plots with vertical splits for all predictor dimensions, highlighting response. Okay, all right. So now you start talking about spine plot. So I think it's going to be better to put spine plot first, because as I said, you mentioned spine plot in your description of double-decker plot. So I'm going to take this and move it first. Okay, so we can do this here. All right, so that will go here, and then this one here, this we do not need. Okay, and then that will be our section on double-decker plots. Okay, let's see. So let's look at okay. The spine chart is a type of visualization that shows at a glance how one area compares with others across a range of indicators. Now, if I read this, I do not understand what it means. What do you mean by area? What do you mean by indicator? These things are not defined, so I cannot figure what this means. All right, so let's see. Let's look at a spine chart. So what can you see about a spine chart that is different from a bar chart? Okay, the big difference. It looks like a bar chart, but the bars have different widths. Okay, so you can say the spine chart resembles so it can closely resembles a bar chart. Bar chart, but differs in that the width of the bars shows relative sizes the categories. We should say now to explain what this means. You should say, for example, let's find the first spine plot that we have. This is figure 3. Is this the first spine plot? Perhaps. It looks like, let's see if figure 3 is the first spine plot. Okay. I think there's a bar chart up here. Let's find out where figure 2 is. All right, this is figure 2 here. Okay. 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 So here we can say, for example, so let's go to figure 3. All right, so this figure is called fig 6. Okay. So I'm going to copy this, and then we'll go back. Then, for example, ref figure 3, figure 6 shows several spine plots side by side. The first plot. The first plot on the left shows the division between okay, let's see. The first plot on the left involves three variables. No, only 2 variables. Okay. So it involves 2 variables. Our urban origin, and then it's going to be no or yes. No or yes. Okay. No or yes. It involves 2 variables, each with 2 categories. Urban origin, no or yes. Okay. Let's see. Say describes. Okay, we can say pertains to. Okay, or yeah, relates to 19, 21-year-olds in South region, and involves 2 variables, each with 2 categories: urban origin of the okay. Okay, yes, and university student. Okay. Okay, so let's see. Okay, so, okay, let's see. Okay, let me say individuals, old individuals in South region of Sudan. I could say each individual we can say, so each individual is either of urban or rural origin. Or I can say, let's say rural or urban origin. Okay, and each, then we can say, and each individual is either not a university, and either so either is or is not a university student. Okay, and here well, let me put urban or rural. Okay, let's see. Okay. Okay, so let's see. So let's see. Um, uh, so thus we are considering two variables: urban, no, yes. Okay, we're considering two variables with two categories. Urban, no or yes, and university student, no or yes. Okay, let's see. So now we want to say the spine plot shows the relative sizes of all four categories okay by means of the areas. Okay. All right, let's say we can say the bar above no shows the division of rural students into rural individuals into university students, non-students. We can say the colored bars so we can say this is similar to a conventional bar graph. However, the width, we can just say as in a conventional bar graph. Okay, the width of the no bar is proportional to the number of rural students, while the width of the yes bar is proportional to the number of ES students, of the number of university students, of rural individuals. It's the number of urban individuals. Okay. Okay. Thus, this relative sizes of all four combinations can be immediately seen based on the sizes, relative sizes of corresponding colored rectangles. Okay. Okay, and we can say in this figure, so I have to say figure here. Okay. So in figure 3, several spine plots are compared. Okay, so you can say spine plots. Okay, you can say corresponding spine plots for different regions are compared. Let's see. we can say, okay, or I can say this makes for easy comparison between okay, in South region, okay, between different regions, as shown in figure which gives spine plots for all 7 regions. Okay, all right, so that's good for spine plot. All right, so I think I can take this here. I don't think we need to talk about this turtle, these here. And I can put this citation somewhere else. Okay. You can say more complicated varieties of spine plots may also be constructed as described in reference. Right. Okay. All right, now, so again, this here, you need to relate double-decker plots to something that you already have. So let's find a double-decker plot, and we can explain double-decker plots using the double-decker plot that we have. Okay, let's see. Okay. 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 I should say here also, all right, it is important to realize when bar charts, when spine plots should be used instead of bar charts. Okay, so okay, we can say note that spine plots should only be used when the relative frequencies corresponding to the different bar variables are meaningful. For example, here we can say this. In this figure, in figure, this is ref, a bar chart. Okay, because the frequencies of the different bar categories depend on independent sample sizes, and thus should not be compared. and thus should not be compared. Okay. All right, now double-decker plots are an enhanced version. Okay. 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 Are an enhanced version of SpinePlot, in which the okay, and then I can say in which bar widths let's see. Okay, which represents 3 variables instead of 2. Okay, let's see. Okay, okay. Okay, relative frequencies for 3 variables instead of 2. Okay, for 3 categorical variables. Okay, let's see. So let's go here and find one. No spine plot here. We have very few spine plots. Not a spine plot. Not a spine plot. Here's a spine plot. Okay, so here we can see. Or here's a double-decker plot. So this one is called. Let's see. This one's called this here. Okay, so let's see. We've got this. So it's figure ref. Okay, is an example of a spine plot. Let's see. Okay, let's see. Okay, is a spine plot that represents the 3 variables. That represents 3 variables. 3 categorical variables. And then the first one would be, let's see, first one is GPA rank. Okay, above or below 50%. Okay, and then the next one is this one is see, I'm not sure which one is which. Is this university region or is this home region? All right, this okay, so university region. Okay. Okay, so region, or you can say region of university attended. Okay, we can see 7 categories. Or you can say region attended of university attended by the student. Okay, 3 categorical variables that characterize Sudanese. Okay, which characterize Sudanese students. Okay. Okay, and then you can say and region of origin, of students' origin. There's 7 categories. Let's see. Let's see. So I can say each bar bar in the plot corresponds to a single GPA category. See, what I'm doing is I'm explaining the plot referring to an example. If you don't refer to an example, then the reader cannot understand what you're saying. Okay. Good. So each bar in the plot corresponds to a single GPA, okay, for students from a single region. Okay. And then we can say the colors in that bar represent the distribution of okay, like we can say division of students in okay, let's see, correspond to students in a single GPA category from a single and from a single region. The division of these students among let's see, division of regions. Okay. Okay, represent how these students universities are divided among the different regions of Sudan. Okay, let's see. We can, all right, so you can say, so in this case, the relative widths of all bars of any two bars can be compared. For example, from the plot, we can see that the number, you can say the number of students with GPA rank above 50%, the number of Darfurian students with GPA rank above 50% is roughly equal to, let's see, it's this one is about the same width as this is about the same width as this one here, the number of northern students with GPA. So this, so these two widths are about the same. So is roughly equal to the number of northern students with GPA rank below 50%, because the corresponding bars have roughly equal, have almost the same width. Okay, and I think that will let's see. Okay, so I think that we want to put this here. Let's I can put this reference here. Okay, let's see. Okay, let's see. Okay, so you can say this enables a more detailed comparison among categories. Okay. And then let's say okay, I think that's where I'm going to. I wanted to give an example, but I'm okay. So you see, for example, we may conclude that that the number of students from COSLA, the number of students, let's see. Okay, let's see. Well, let's see. I'd have to think for a good comparison. But let me stop here because I'll think of a good comparison, but let me stop here.